Whenever you're looking at trigonometric identities and you want to prove them, again, you do not use the identity as it's written and assume that it's true and then prove that it's true. That's a very, very common mistake, and it leads to a fallacy commonly known as the ends justify the means. It doesn't matter what I did, it still works, so what? Who cares? I got the right answer. Why does it even matter? Well, it matters for a lot of different reasons. And in terms of artificial intelligence, if you were training an AI model based upon the fallacy that you're doing, it might work in one situation, but it will take those skill set that you're trying to teach it, that's learning from, to apply to another problem, and it can completely destroy it. And that doesn't really seem like that's all that important until it becomes really important, like and you're doing some stuff with nuclear facilities. Okay, that can be a little nuclear. It can blow up, so you gotta be a little careful. Okay, I'm taking it a little bit the extremes there, but you guys get the point. Okay, so don't work the equation simultaneously, in other words. That's a very big mistake. Work one side and reach out to the other side. You can work left-hand side first if you want, work the right-hand side first, it really doesn't matter. What you want to do is work a side that has enough information so you can get some traction on the problem. And if you're not getting any traction, try the other side. And at times, what you want to do is work a problem, maybe the left-hand side, you go as far as you possibly can, then that's it. Then you work the right-hand side, go as far as you possibly can, and see if you can find some way, as the song would say, meet somewhere in the middle to link things up. In this problem, I see I have a fraction on the left, I got a fraction on the right, and I kind of like fractions, when we start looking at identities, because it gives me a lot of things I can work with. I can incorporate some ideas of fractions, such as how to add up fractions. You got to get a common denominator. And if I have a fraction, I can take it, I can also split it apart. But something up here that's making me a little bit exciting is when I look at the denominator, I'm not really concerned right now about the numerator, but when I look at the denominator, there's two terms, it's a binomial, and I know different properties, different identities associated with binomials. In particular, the binomial theorem. That might be something that I might want to consider. So something like a plus b, quantity squared, a squared plus 2ab plus b squared. I might want to do this. I may not want to do that. But you see what I'm doing? I'm starting to develop some kind of strategy, putting some things together. I'm building off a knowledge base, skill set that I already have in place. Okay, so I might want to do this. And the reason why I might want to do this, also because I do see a tangent, I see a cotangent. And when I see a tangent and cotangents, I get a little bit excited too. Not just because I want to take a nap, cotangent, but tangent squared theta plus 1 equals secant squared theta. And also cotangent squared theta plus 1 is going to equal the cosecant squared theta. So you got your Pythagorean theorems. You might want to use these. It's on the table for discussion. I might use it, I may not use it, but it's something I do want to consider. But I also see something else. I see this minus sign, I see a plus sign. That makes me very excited. Spidey sense goes off because now I'm thinking, okay, this might be part of the discussion, but I'm pretty sure that the difference of squares identity is lurking right around the corner. Okay, so I got a good plan of action now. I see I have cotangent theta plus 1, cotangent theta minus 1. I just want to work the left-hand side and see what happens. Okay, so maybe I want to apply the difference of squares identity. So I can maybe go this direction. And then from here, maybe I can apply a squared minus b squared. Up top, maybe I can apply the binomial, maybe I can expand out. Maybe it's something like this. And again, what I'm trying to do is just show you guys how you can start thinking through some of these problems. You're not always going to know exactly the direction you're going to go at any given stage, what you just want to do is kind of look at the evidence, look at the derivations, and just go where the evidence is going to lead you. Okay, well, I do have a cotangent theta plus 1, and I know I can replace that with a cosecant square. That's Pythagorean theorem there. That's possible. And I know I can also maybe interject something here as well. That could be something that I might also want to consider. It's something that I might be able to do like this. Okay, so cotangent theta plus 1, I can say cosecant squared theta. And then down here, okay, I could technically subtract off 2, and then I can say cosecant squared. You know, I can do that, but I don't really see how that's really going to help. I mean, there's a lot of things you can possibly do. In situations where, like right now, it seems like we're kind of getting into a dead end. I'm not really seeing where this is going to materialize. All the derivations are correct, but I'm still not seeing how this is going to lead me to here. I might want to just abandon the left-hand side. And this is what's going to happen whenever you start doing your work. You're going to say, okay, I don't see how this is going to work. Let me just see maybe what's going to happen on the right-hand side. So you might want to explore that for a moment. Okay, now again, I do see the 1 plus tangent. I see the 1 minus tangent. I do see an echo of the difference of squares. I do see the binomial theorem popping up. But I also notice that there's some symmetry here between the left side and the right-hand side. And I got a little stuck over this side, approaching it from this perspective. So I probably don't want to do that again. Otherwise, I'm just going to be doing the same thing. So I said, okay, well, I got to change directions and try something else. And if you're not for sure as to maybe which direction you can go, you can always take the problem and nuke it. And what I mean by that, take all the tangents, cotangents, secants, cosecants, and you can re-express them all in terms of sines and cosines. You know, take it down to its most primal essence. Okay, so you can say this. Okay, it is a possibility. Okay, now after you have this, you know, you might want to have a fraction in the numerator, fraction in the denominator, and you just keep exploring the problem out. Just keep filling it out. Okay, so maybe you want to combine the fractions. Okay, and we have a fraction divided by a fraction. Keep the first fraction, flip the sign, look at the reciprocal. So the whole entire keep, change, flip. So this would simplify down to cosine theta plus sine theta over cosine theta, cosine theta, and minus sine theta in the denominator. Cosines divide out, and now you're left with cosine theta minus sine theta. Okay, now as you're going about the problem, what you want to do every so often is just take a sneaky little peek, come back over here and ask, am I heading in the right direction? I got to go here. Okay, again, this didn't really lead me anywhere. That's very, very helpful. So I want to maybe keep pushing on this a little bit more. And again, there's lots of things that we can do. But let's go back over here to the left-hand side. And suppose that we take the left-hand side and if we nuke this side as well. Okay, and whenever I see a fraction divided by a fraction, I get that itch. I want to scratch that itch, combine the fractions, common denominator. And if I do keep, change, flip again, I see it. I see it, don't I? Because whenever I simplify it down, I get that. And the direction I'm taking this problem over here, because I wasn't able to see maybe the Pythagorean theorem, how it's going to be very helpful, but by taking it in terms of sines and cosines, it made it a lot easier as to what I'm going to do. And again, you're just following the evidence. One step after the next, doing a little simplification, a little bit of manipulation. And again, you can take this problem, you can go a lot of different directions with it. That's why ever so often when you're going through the problem, come back over to the other side, take a little sneak little peek, and then they say, okay, I got this. I want to meet in the middle right here. So basically, I can take everything I have here and I can just kind of reverse the process. So in other words, I can say this is going to be cosine theta plus sine theta all over sine theta. And then cosine theta minus sine theta all over sine theta. And if I did not explore the other side, there's no way I would have thought about this. But because I explored the other side and asked, okay, where do you go to make this thing link up? I got it. Okay, so just keep going through the process. This right here, which was here, which then I can take this and take the fractions and break it apart. So we'll have cosine theta over sine theta, sine theta over sine theta. Break the fraction apart, break the fraction apart. Cosine over sine as cotangent plus 1. Cotangent minus 1. Did I show what I needed to show? Left-hand side equals the right-hand side. So again, this just kind of shows you that when you go through the problem, sometimes you will get stuck. Don't think of getting stuck as, it's a failure or you just can't go any further. Just remember what failure really means. It's your first attempt in learning. If you are not courageous enough, daring enough to make a mistake, you're never really going to learn anything. You have to be courageous enough to be wrong and willing to be wrong so they can learn how to be right. So again, we got stuck. And because we got stuck, we were courageous enough to make some kind of idea, get started. We realized, okay, it does work sometimes, but maybe not in this situation where I want to apply the Pythagorean theorem. It might have been better if we would have done sines and cosines as this is showing us, because it really opens it up a little bit more. Okay, let me stop, see if you have a question. I know this is getting pretty dense. Okay, so I got to show the left-hand side equals the right-hand side. So when you look at this problem, what goes through your mind? What do you see here? What could you use to your advantage? And sometimes when you look at a problem, if you're kind of like me, sometimes you look at a problem, you look at something like, that looks pretty complicated. Or I'm a little bit scared of maybe the fractions, or maybe I'm a little scared on the other side. When you're feeling that kind of pushback, lean into it. It's usually indication that that's probably where you need to go. Don't fear it. Or like what I like to say is, be a math hero. Run towards the danger. Okay, so let me give you a moment here. See what you can see. What could you do? What's your strategy? So I got you the left-hand side, it's equal to the right-hand side. And I might want to just kind of, peek at the left-hand side and then peek at the right-hand side and see if there's something I can do that can really help out. On the right-hand side, I have cotangent, I got cosecant, and I know cotangent, that's going to be cosine over sine. So just do a little bit of scratch work real quick. We'll see cosine theta over sine theta, and then the cosecant, that's going to be 1 over sine. And that's going to lead us to a cosine over sine squared. I don't really see what I can do on the right-hand side to get me to these fractions. I really don't see that from this. And if you can, great, that's fantastic. Show me how you do it. So what that's kind of telling me is, maybe I want to work on this side first. Maybe there's enough traction on the left side that when I start simplifying down, I can go over to the right-hand side. And as you keep working through these problems, you're going to start developing the insight. And that's what you're looking for. You're going to develop the insight, the intuition as to how you're going to go about the simplification process. And whenever I see fractions again, experience has taught me that I probably want to add up the fractions because I look at it from this perspective too. This side's a fraction. This side's not. A little different perspective, right? What can I do to turn something that's a fraction into something that's not a fraction? And I want to maybe explore that idea. Also, when I look at the right-hand side, I see something that's mighty suspicious. Sine squared. Again, what I'm doing is I'm just exploring. I'm gathering evidence. I'm being a scientist. And I know something about sine squared. I know it relates to the Pythagorean theorem. Sine squared theta cosine gives me 1. And if I solve for sine squared, that's 1 minus cosine squared. And now I'm starting to really see this. I got 1 minus cosine theta. I have 1 plus cosine theta. Okay, now I come over here, I check the left-hand side. I get really excited. Because look at this. Look at that. I saw it over here on the right. So that's giving me the clues, giving me the idea that I probably want to start combining fractions, hit it with the Pythagorean theorem, and simplify it down so I can turn something that's a fraction into something that's not a fraction. Okay? You see how that strategy is kind of coming together? I'm just exploring for the moment, putting all my options on the table and see what I can do to generate something, to manufacture some kind of strategy. Let's just look at the left-hand side. Combine the fractions, and we get a common denominator. A plus b, a minus b. Up top, you have 1 plus cosine theta, all squared. Subtract it off, 1 minus cosine theta, all squared. So 1 minus cosine squared theta. That's Pythagorean theorem. Okay, now for the other part, we're going to take this and expand out. So 1 plus cosine theta plus cosine squared theta. Subtract it off, 1 minus 2 cosine theta plus cosine squared theta. And the 1 minus the cosine squared theta. Earlier we noticed that we peeked on the other side, remember, and we saw the sine squared. So that's giving us the idea that I might want to go ahead and express this now in terms of sine squared. Distribute. So now you have plus and minus. Okay, ones go away. 2 copies. Cosine squared goes away. And I want to get this into the form that I need to get to. Right-hand side had a cotangent, cosecant. So I want to take this fraction and use properties that we know of decoupling it. Because how do you multiply fractions? Numerator times the numerator. Denominator times the denominator. Cotangent. Cosecant. Did I show what I needed to show? Did I go from one side of the equation and get to the other side of the equation? Sure did. We're done. Okay, now again, there's lots of ways how you can navigate through the problem. There's lots of different trig identities that we're starting to see. You can use the trig identities however you like. You just got to make sure it's valid. Pythagorean theorem is a really good choice to use. All right, questions about it? For this problem, I look at the left, I look at the right, got to make some kind of adjudication. Okay, which place do I want to start off with, the left side or the right-hand side? And I don't know, there's some things I can definitely do on the right-hand side. I can see that. And also some things I can do on the left-hand side. But I get a little more excited on the left-hand side because there's a nice identity that I can use. I have 1 minus cosine squared. I got 1 plus cosine squared. Where have we seen that before? Difference of squares again. That difference of squares identity keeps popping up a lot. It's like a whack-a-mole. It pops up here, pops up there, pops up here. It's popping up here. So you have a minus b, a plus b. Okay, so you got something like that you can, start playing around with. Okay, but also notice on the other side, you got sine squared, you have sine to the 4th. So you got to figure out some way, somehow, to interject a sine into the problem. Well, I expanded out correctly. I did apply the difference of squares identity, but I kind of went maybe a little bit too far. Because over on this side, I see a bunch of sines. Over on this side, I don't see any. I only see his cosine. So although, yeah, this is correct, I do want to inject sine, so it might have been better if I said, well, hold your horses. Instead of saying cosine, why not if I say sine instead? Because now, when I apply the Pythagorean theorem, there is no more cosines on the other side. And that's exactly what I want. Something where there's no cosines on the other side, only sines. Now from here, I just want to take this and expand out, do a little manipulation. So I have 1 minus 2 sine square theta plus, take this and square it, apply the binomial theorem, sine to the 4th theta. And then again, distribute the negative. When you do so, the 1's are going to go away. You're left with 2 sine squared theta minus sine to the 4th theta. Is that what I needed to show? Absolutely. So again, when you're going through these problems, you want to use the tools that you have. Pythagorean theorem is a really, really good resource that talks about the difference of squares. It's just lurking around the corner. And sometimes it's possible to go a little bit too far. Not too big deal. Just back up a little bit, like we did. And note what we have on the right-hand side, as in this problem, there were no cosines, so it would have been better if I got rid of the cosines at the very beginning, tried everything out for sines, and then just see where the evidence is going to take me. And if I get there, great. If not, I'll just keep grinding it, keep turning it, do what I got to do so I can actually get from the left-hand side to the right-hand side. And in the event where it's very complicated, where I can't really see how to go from the left to the right, I might want to nuke the problem, turn to sines and cosines, in other words, find some way to link it up that way. Or find something I can do to link it up by applying some different type of identity. Sometimes, yes, you do have to meet in the middle. Sometimes it's possible to go all the way through. All right, let me stop. I do want to see if you have a question or a comment. Okay, well, what we're going to do is we're going to keep looking at these expressions. We're going to keep digging a little bit more into trigonometric identities. And there are, once again, lots and lots of different trigonometric identities. And there's some of them that we do need to make sure we're very aware of. Pythagorean theorem is all 3 different cases, the ones for sine, cosine, tangent, secant, cotangent, cosecant, those 3 different ones. You got to know those. But there's some additional ones which are going to make things a whole lot easier. And we're going to talk about some of those next time, where we start taking the angles on the inside and we start tinkering with them. Like an engineer, we start tinkering with certain values and see what's going to happen. So we're going to start adjusting some of these angles and get some different identities from those. We can use those also to help us with different situations to solve different equations. Okay, guys, that's all the time we got. You have a great day. I'll see you next time.
I hope that today's lesson was a positive and an encouraging learning experience, and that you have a better understanding of how to solve these problems. Be sure to set some time there today and throughout the week to review these concepts, to rework these examples so that you're better prepared for the next lesson. If you need anything, just let me know. You're always welcome to send me an email or to stop by during office hours. Until next time, keep up the good work and have a great day.